action.
So we're off. Number one is stoichiometry, which is a fancy word. Two, you have 5 choices. Tomorrow when we do the quiz, you'll need all 5 of these choices. So I'll relay these again in a minute, but if you want to be a helpful friend, you could jot down the 3 to 5 of them that they don't have. But one would be reactants and products. 2 would be the moles of each of those. A third could be the molecules of each of those. A fourth could be the relative masses of each of those. A fifth could be the volume of gases. But if you missed that, I'll recap that in a minute when people have their own papers back. 4 is the mole method. They said it real big in the reading with exclamation points. Think mole, exclamation, exclamation, exclamation. There were at least 3 of them, I think. But 4 is the mole method. If you put dimensional analysis, I would take that because they also said in the reading something about dimensional analysis being a part of that, which it definitely is. Tomorrow we'll have a big board full of dimensional analysis to do, but not quite yet. 5, you've got 3 choices, you just need 1. So the first step is going to be to figure out the moles of what you know. Second thing you're going to do is figure out the moles of what you don't know and you're trying to know and want to know. Third thing is going to be to figure out the mass or the volume of something that you don't know. And then 6, there's going to be 3 types of problems. There's mass-mass problems, meaning that they give you A and expect you to find a different mass of some different thing. There's mass-volume or volume-mass problems, which means they'll give you a volume or mass or one thing, and they'll want a volume or mass of another thing. 1 volume, 1 mass. The third was volume-volume, where they give you 1 volume of 1 gas, and they'll want you to find another volume of another gas. And that's what our items are about. Question about scoring something while it's still with you? So let's give those back and I'll fill in the blanks of what this stuff means and what you need to know for next time. So there's not any homework tonight. The only thing you could do if you want to lay a foundation of homework is to do problem 1A. There's like one definition you could do that's part of a much larger scheme of what would be due in 2 days from now. You can't really do the 2-day from now stuff until first you break things, and then after that, get some math examples tomorrow. So tomorrow's read is 10.4. The majority of what you'll read in 10.4 is just like example after example, page after page of math, which I realize you probably don't read. You probably wait for me to just show up and perform that like a little math show. But in the midst of reading this, there are going to be 7 points on and off. They'll get into some vocabulary stuff. So 7 new points of reading from 10.4. I'll try to resist making a CB joke about 10.4. Number 1 becomes a 2-point question. So number 1's question will become, what is this chapter about? Which is stoichiometry. And then a follow-up second point would be to define that word. So if you go from measurement to the end, you've got it. It's the measurement of the relative quantities of reactants and products in a reaction. 10 to 14, we're going to go list of 5. So there's 5 things we can talk about if you have a balanced chemical equation. One is what the reactants and products are. Second thing was the molecules of each of them. Third is the moles of each of them. Fourth is the relative masses of each of them. The 5th one would be volume of gases. So today's number 2 and 3 becomes a 5-point question. Anybody need a rewind on that? I'll explain that better whenever we fill in the other sheet that you should have had another sheet come down your road to you with a bunch of blank spaces on it. 4 stays the same, just filling in the blank with what's called the mole method. That's not going anywhere. 5 becomes a 3-point question. All of the problems are going to follow this format in this chapter of step 1, find the moles of what you know. Step 2, find the moles of what you don't know. Step 3 is find the mass or the volume of what you don't know. So 1 was find moles of known, 2, find moles of unknown, 3, find mass or volume of unknown. 6 will become a 3-point question next time. So mass problems were 1, mass volume, or say it backward, problems are 2, volume problems are 3, and that is what we have. Question about what you're trying to absorb for next time when I see 7 new ones and then all those changes.
What's the third one?
Probably find the mass or volume of the unknown. Anybody else need a rewind? So let's look at the other paper that I gave you. So the diagram at the top is hopefully still semi-familiar to you from quizzes long ago. Is that a diagram you saw? Yeah. So what's the center box, the most important box that has arrows coming out of it to all the other boxes? That is moles. So moles is the center point of the math you did a couple chapters ago, and it's the center point of this chapter. Everything runs through moles. What's one of the surrounding boxes? If you know moles, what's one thing that you could find? Volume would be one. So in one of the surrounding boxes, any of the surrounding boxes, put volume. And along the transitional arrow, how do you get from volume to moles, moles to volume? How did you make those transitions a few chapters ago? 22.4 liters is the magic number. So along your arrow, you could remind yourself, if you're trying to get from volume to moles, moles to volume, 22.4 liters in a mole. Any mole of gas has a volume of 22.4 liters, called the molar volume. That's how you make that transition. What was another thing that you transitioned from moles to? Mass. So in one of those other surrounding boxes, fill in the empty box with mass. How did you jump from mass to moles, moles to mass, jump back and forth? What tool did you use? Periodic table. So periodic table let you jump from moles to mass, mass to moles. Let's finish the diagram and then we'll do some stuff with mass down below in a minute using the periodic table when we cross below that halfway line. What's our third thing that you can get from moles to other than volume, other than mass? Yeah, what's that category that would cover that whole amount of stuff? Particles. So particles would be in that missing box. How did you jump from moles to particles? Avogadro's number. So what was Avogadro's number? 6.02 times 10 to the 23. I don't know if she uses the same abbreviations I do, but when I want to write Avogadro's number, I've been writing Avogadro's number like that for a long time. So she's been using that. She stole that from me, and then so did the Avengers. I was using that logo long before those movies came out. So Avogadro's number, 6.02 times 10 to the 23rd is how you make that jump. And by particles, we mean atoms, we mean molecules, we mean a thing you memorized and hate. Ions. Another thing that starts with an F. It's a two-word thing. Formula units. All of that stuff falls under the category of particles. We're not going to so much be dealing with particles this chapter. It's more going to be the mass volume stuff. So more periodic table, more 22.4. But the way scientists people write books, I have to believe they're going to use Avogadro's number sometime because it does fit in this context. Question about the top of that diagram, a little refresher on how you used to transition everything through moles. Let's do some masses just to start our stoichiometry career. So here's a balanced equation. What's one of the 5 things we said it tells us? Reactants and products. So what's one of the reactants? Not exactly.
C2H6.
Yeah, and I don't know what that's even called. I'd have probably said oxygen because I know that one better. But that's our 2 reactants are C2H6 and oxygen. What's one of our products? Carbon dioxide and water. So it tells us the reactants, it tells us the products. What was another thing it tells us?
Moles.
The moles of each. So if I told you that you had 7 moles of oxygen, you could comfortably tell me that you have how many moles of carbon dioxide?
2.
Nope.
4.
4. Or if someone told you you had 4 moles of carbon dioxide, you could comfortably tell them you have how many moles of water?
6.
6. Because where are you looking?
Coefficient.
the coefficients, which is a fancy word that means those big numbers in front. Those tell you what moles you have. What was another thing we said?
Molecule.
The molecules of each. So if I told you I had 7 oxygen molecules, you could probably comfortably tell me that you have 4 CO2 molecules and 6 water molecules, just again looking at the coefficients. What else did we say we could do from looking at a balanced chemical equation?
Volume of gases.
Volume of gases. So that would take some math. If I told you how much oxygen volume I had, you could tell me how much CO2 volume I had, but maybe not all of you, maybe not yet, maybe not till later in the chapter. But what would we work through if I'm talking about volume of gases? What would we have to work through? 22.4 math. Okay, so we'd have to take the 22.4 to get moles figured out, use some more 22.4 to get other volumes figured out, but that equation will do that for us, but not today. What else did we say?
Relative mass.
Relative masses of each. So let's play a quick mass game. So if we look at C2H6, and I have 2 moles of that, because I'm just going to keep life simple and use the coefficients as my mole count. If I tell you I've got 2 moles of C2H6, somebody tell me how many grams does that make?
Isn't it like 24?
No.
16.
No. 2 moles of C2H6. What are we going to have to use to do this math? Periodic table.
Is it 36? Wait.
No. No. Two moles of C2H6.
Is it 60?
Yes. How did that wise woman in the front row get 60? Yes.
It's like the mass number on the periodic table. And then you're like,
Okay, let's use actual numbers we're finding on the actual table.
it's
C is 12.
C is 12, so you need to take 12
Times
Four.
times 2 is 24. Or times 4 if you're shortcutting it, I get what you're doing. But most people would go, the 12 times 2 is 24 for C's. H's number is 1 times 6 makes 6. 6 and 24 you have to add. So C2H6 is generally responsible for 30. But for this problem, because the coefficient was a 2, 2 30s makes 60 grams for C2H6. So on your little paper you could fill in 60 grams in that first line. Then let's go after 7 O2s. How are we going to do the math on the O2? 7 O2s. 16 for oxygen, times 2, and then times 7. So 16 times 2 times 7, or 16 times 14 if you like doing partial math in your head. $224. So for our reactants, let's do a grand total. What is your grand total of grams from before the reaction occurred? 284 grams total is true. Question about the math we did on the left half? So let's do some math on the right half. So we've got 4 moles of CO2. Talk through the math.
Times 4.
You could do 12 times 4. Then oxygen you would do,
32 times 4.
we could go 32 times 4. Add those together.
176.
176. There's multiple ways you could do the math. People that aren't math great are probably more comfortable taking a 12 for C plus 2 16s for O, getting that result of 44, and then going times a 4 when they're done with that to get the 176. But all roads that are correct lead to 176. Question about 176? 6 H2Os
108.
is 108. How do we math that?
Just subtract from 284.
Well, if you're gonna cheat, yeah, you're spoiling it. You already saw what's coming next. If we're just basing it off the formula 6H2O, how would you math 6H2O?
Well, there's 2 hydrogens.
2 hydrogens makes 2.
Yeah, and then oxygen is 16.
So 2 and 16 is
18.
18 then times 6. So we're 108. So after the arrow in the product world, what is the total grams over there? 284. Which shouldn't surprise you if you've been paying attention all year, because you learned a thing that said that mass can't be created or destroyed. So the mass afterwards should match the mass beforehand. You can't have your mass going anywhere. It's got to be the same. But that kind of math you're going to do a good bit in this chapter. Like going to the periodic table and worrying about how many grams you're getting out of all the different formulas, that is a thing. Balancing equations, still a thing. What you're hoping for in the homework is that they'll say, equation was already balanced for you. And I feel like from my memory, there are more that are balanced, but there are quite a few that they'll say, here's an unbalanced equation and you'll have to balance it. So your skills from chapter 9, if they stink, stank, stunk, you need to continue to try to build your balancing skills, because that didn't go away. That's still here. So this chapter is basically a marriage of your balancing chapter with your mole, gram, Avogadro number chapter. You put those 2 chapters together into one, and that's what this is. There's not a whole lot of really new information, but they're using that to actually do stuff that people do. Hey, I've got this many grams of oxygen. How much CO2 can I make? That people like do that. You don't do that, I don't do that, but people do that. How much stuff can I make out of these ingredients? Question about that? All right, can you hit the stop?
Is it the same button?
Yep.
But